Okay, so I'm going to go over these 8 problems that involve graphing sine and cosine functions. The directions say to identify the amplitude, period, reflection, and vertical shift, if applicable. Something super important that some of you might leave out are the key points. Now, your key points must be clearly visible on the graph, and in every single one of these problems, I show you how to find key points. I'll explain more what that means in a bit, but for now, I just want to first start off by identifying what these functions will look like. Now, you'll see these functions look something like y equals a sine bx plus c. Right, so you'll see it take that form, or alternatively for cosine, it's going to be y equals a cosine bx plus c. All right, so it's always going to take these one of these two forms. Now, couple things that these letters A, B, and C tell us. A is going to tell us what our amplitude is. Now, our amplitude is always going to be the absolute value of A. All right, so whether it's positive or negative, we're always just going to take the positive, and that's just going to tell us how high or low the function is going to go. All right, our period. Sine and cosine both have a period of 2 pi generally. So if there's something else inside of the sine or cosine function, you're going to divide by that number, and that's going to be divided by b, whatever's inside of the function with the x. All right, now reflection depends on a. So if a is positive, you're not going to have a reflection. If a is negative, then you are going to have a reflection. All right, now vertical shift is only going to depend on c. Right, it's going to go up or down c units. So up c units or down c units, depending on if it's positive or negative. All right, so maybe I could make a note of that. So up if c is positive, down if c is negative. All right. So let's first identify in this first example what our amplitude and period are. All right, so our amplitude in this case, keep in mind it's always going to take the form of a sine bx plus c. Our a value here is going to be whatever's in front of our sine. In this case, it's 4, so our amplitude is just going to be 4. All right, our period is going to be 2 pi over b. B is always going to be the number that's inside of the sine or cosine function with the x. It's going to be sine of 1x. Right, if you don't see a number, you assume it's 1. All right, so that's going to get us 2 pi over 1, which is just 2 pi. All right. Now for our reflection, you're looking at the sine of A. And in this case, A is 4, positive 4. If it's a positive 4, we're not going to have a reflection, right? None. All right, and we don't have a C value, right? I'm not adding or subtracting a number to our sine function, so we're also going to have no vertical shift. All right. All of this information is going to help us graph these functions, right? So I'm going to outline exactly how you would do these kinds of graphs, right? So it might be a lot of steps. Well, not a lot of steps, but the steps itself are kind of lengthy, right? So to graph these, the first thing that I would do is I would find 5 key points. Right, not just random key points, right? I'll show you exactly which points we're trying to find. All right, so I want to find 5 key points and then label it on the axes. All right, 5 key points, label the axes. Or just the axis, right? Just the x-axis. I'll make that a little bit more clear. Label the x-axis. All right, the next thing we want to do with these 5 key points, we're going to graph one cycle. Remember, a cycle is just one wave or pattern in a sine or cosine function. Graph one cycle using the 5 points, the amplitude, and the period. All right. Now this next step is not always going to be used, but if you have a reflection or a shift, so I would reflect, this is when you would do it. So you would reflect or shift if applicable, right? If you don't have any, you would just skip it. Right, and then once your one cycle is complete, right, so this is all for one cycle, you would just complete the graph in both directions. Right, in both directions. All right, so the first thing I want to do, I want to find my 5 key points. Right, so I'm just going to label that first. So my key points, the first one on your axis is going to be 0. We're always going to start at 0. All right, that's going to be one of them. The next 3 are going to be at quarterly intervals of your period. Now the period in this case we had said is 2 pi. Right, so I'm going to use quarterly intervals of 2 pi, meaning I'm going to start with 2 pi times a quarter, 2 pi times 2 quarters, which is a half, and 2 pi times 3 quarters. All right. And then, okay, so that's 4 points. The last point is going to be the period itself, 2 pi. So all the way from 0 to 2 pi, that covers one full cycle. All right, now from 2 pi times a fourth, all right, you can cross cancel, you can cross out the 2 and the 4 and make it 1 and a 2, or you can multiply straight across, right? 2 pi times 1 is just 2, and we get 2 pi over 4 on the bottom. And then simplifying this, 2 and 4 can simplify, this gets us pi over 2. All right, now for our halfway mark, it's going to be 2 pi times 1, which is 2 pi, divided by 2, and then your 2's can cancel, and then we end up with pi. So that's your halfway mark. Now the 3/4 mark, it's going to be 2 pi times 3, which is 6 pi, divided by 4, and then 6 and 4 can simplify, that's going to get us 3 pi over 2, and then 2 pi, right? So these right here, these are your key points, which we're going to use to label our axis, our x-axis. All right, so I'm going to go ahead and do that now. All right, so I know that 0 is going to go right here. It's an unlabeled axis, so it doesn't really matter how you do it. Our quarterly mark is going to be at pi over 2. Halfway, it's going to be at pi. 3/4 of the way is going to be 3 pi over 2. And then the full period is going to be 2 pi. All right, so it's going to look something like that. All right, using these 5 points that we got. All right, so that was step 1. And then I want to use the 5 points, the amplitude and the period, to graph one cycle. All right, keep in mind our amplitude is 4, our period was 2 pi, and our 5 key points we already labeled on the axis. If our amplitude is 4, that means it's going to go at its highest 4 units and at its lowest 4 units. So it's going to look something like that. One thing to note with sine is that at 0, keep in mind, now this was from the previous lesson, sine of 0 is going to get you 0, right? And this relates back to that little circular graph that we drew, and I picked a point and I labeled it 1, 0, and I labeled it x, y, I gave you r as 1, right? So it relates to all of that. You don't have to show all of that in this particular, in these particular problems, as long as you know that sine of 0 is 0. That's all that really matters here. Because from here, you would just plot a point right there at 0. All right. And the quarterly intervals are going to give you the points that you want to plot. So at the first quarter, if we're starting at 0, we're going to want to go to our highest point next, which is going to be at 4, right? Our amplitude is 4, so that's our highest point. At the next quarter, we're going to go back down to 0. All right, at the next quarter, at the 3 pi over 2 mark, all right, it's going to be at its lowest, so at -4. Oh, sorry, -4. And then at 2 pi, it's going to go back up. So we're always going to end right where we started. Right, now that's one cycle of this function. We don't have any reflections. We don't have any vertical shift. So we can draw this cycle as follows, right? This one cycle. It's going to look something like that. Right, and if you remember from previous activities, this shape itself is familiar. So now all you have to do, right, that takes care of the second step. We didn't need the third step because we don't have any reflections or shifts. Now we want to complete the graph in both directions, right? This is where you can kind of, I don't care if you're super precise with it, as long as you have the correct shape, right? So something like that is fine. And then if you go in the other direction, something like that is fine. All right, so your graph should look something like that, and that completes your graph. All right, so a little bit of a lengthy process. It's not super difficult steps. They're just steps that might take a little bit of time, right? And on the quiz, I'm for sure going to want to see key points, right? 5 key points labeled correctly. All right, that's going to be where a majority of your points come from. All right. So let's just keep this process going for the rest of this problem set. All right, so let's keep it going for number 2. I want to first answer these questions: the amplitude, period, reflection, and shift. All right, so amplitude, do we have a number in front of our sine or cosine function? Right, this is a sine function. I don't see a number in front. You assume it's 1. Absolute value of 1 is just 1. Right, so that means at its highest, it's going to go 1 unit. At its lowest, it's going to go 1 unit. All right, our period, our b value is whatever is inside of the sine function with the x. In this case, it's 5. We're going to divide by 5. So 2 pi over 5, that doesn't simplify, so we just leave it like that. Reflection, we don't have any reflection here. I don't see any negatives, so I'm going to write none. And then vertical shift, we have a +2. So we're going to shift our entire graph up 2 units. All right. Now, this is when I would find my key points. So remember, 0 is one of them. And then the next 3 are going to be at quarterly intervals of your period. Right, so 2 pi over 5 times the 4th. 2 pi over 5 times a half. 2 pi over 5 times 3/4. All right, and then our last one's just the period itself, 2 pi over 5. All right. 2 pi times 1 is just 2 pi. 5 times 4 is 20. We get 2 pi over 20, which simplifies to pi over 10. All right, 2 pi times 1 is also 2 pi. 5 times 2 is 10. This simplifies to pi over 5, right? 2 and 10 can simplify. You can also cross cancel for all of these. All right, would get you the same answer, right? 2 pi times 3 is 6 pi. 5 times 4 is 20. 6 and 20 simplify to 3 over 10. So we get 3 pi over 10 for our 3/4 mark. And then 2 pi over 5 is just our last value, right? So we get these values here as our 5 key points that we're going to use to label our axis. All right, so I'm going to label that right here. 0, what was the first one? Pi over 10, pi over 5, 3 pi over 10, all right, and then 2 pi over 5. Our amplitude is 1. All right, so I would use that to go up 1 unit, down 1 unit. All right, and then remember, sine of 0 is always going to start at 0. All right, and then the pattern goes, it's going to go up, down, then all the way down, and then back up to 0. So all of these cycles are always going to end where you started. All right, now your one cycle is going to look something like this. All right, I'm drawing it in a little dashed line just because this isn't going to be our final graph. Remember that we have a vertical shift here. All right, so if we have a reflection or a shift, this is when we would do it. I would take my points and then I would move everything up 1 unit. Or I'm sorry, 2 units, right? We're vertical shift of up 2, right? So I'm going to go up 2 right there, up 2, up 2. All right, keep that going for all of these. All right, and then I'm going to connect them, right? Now this is our final graph, right? I don't have a reflection, so don't have to worry about that. This is one cycle, so as long as you have this and the 5 key points associated with it, perfect, right? That's majority of the problem. Now the rest of it, I just want to see that you continue the graph on both ends, right? This is where I don't really care if you're super accurate as long as you're not messy with your work. So it should look something like that. So that's the graph of your function. All right, hopefully not too bad. All right, now let's try this one. Our amplitude is going to be absolute value of whatever's in front of our sine function. In this case, it's a -3. Absolute value of that's going to be a +3. All right, period. Inside of my sine function, I see an x, so I assume there's a 1 in front. 2 pi over 1 is just going to get you 2 pi. All right, so my period is 2 pi. Reflection, I do see a minus in front, so we are going to be reflecting here. All right, in a vertical shift, we're going to go up 2 units. Exact same as before, we're going to find our key points. All right, 0 is always going to be the first one. The next 3 we're going to get from doing our quarterly intervals. So it's going to be 2 pi times a quarter, 2 pi times a half, 2 pi times 3/4. Right, this is the same period that we used in a previous problem, right? So if you recognize it, you don't need to be super detailed with your work as long as you can clearly label your 5 key points. All right, so we get 2 pi over 4, which is pi over 2, simplified. 2 pi over 2, which is pi, simplified. 2 pi times 3 is 6 pi over 4, all right, which is 3 pi over 2. And then 2 pi is always going to be your last one, right, the period itself. All right, and then I would use those points to label it on the axis. 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, and then now we can start graphing a cycle, right? Our amplitude we said is 3, so I'm going to go up 3 units, down 3 units. All right, and then I would graph one cycle using the 5 key points, my period and my amplitude. No reflection yet, I'm going to do that in the next step. Remember, we always start at 0. We're going to go up to the highest point, then back down to 0, down to our lowest point, and then back up to 0. All right, so this is one cycle originally without any shifting or reflections. Right, now if we have a reflection or a shift, which we do, now's the time to do it. All right, so I would first reflect. All right, 0 on top of 0, it's going to reflect on top of itself. We don't have to do anything to that. This +3 that we see, I'm going to reflect it down to -3. All right, again, 0 on top of 0, it's going to stay in the same spot. This -3, I'm going to move up to +3. And then this 0 is going to stay at 0. Right, it's going to reflect over itself. And then this is what our function looks like reflected. All right, and then keep in mind we have a vertical shift of 2 units. So we have a shift, this is the time to do it. I'm going to move everything up 2 units. Up 2 units. Right, our reflected one. So everything that we just drew in purple is going to go up 2 units. Right, so I kind of go off the graph a little bit, but it's fine. And then this I can fully shade, right, because that's one complete cycle. All right, so that's one cycle. We're almost done. All you have to do is just complete it in both directions. So it's going to look something like that. Again, it doesn't need to be 100% accurate, right? As long as you show that it's continuing in both directions, that's all I need to see. And as long as you have the 5 key points. All right. Let's do one more sine function, and then we're going to move on to cosine. All right, so for this one, same exact problems as before, right? So for our amplitude, whatever's in front of our function determines our amplitude. It's just a 4, so I'll write 4. Period is going to be 2 pi over b, 2 pi over the number inside of our sine function, so 2 pi over 2, which is just pi. I don't see a negative on the outside of our function, so we're not going to have a reflection. And a vertical shift, I see a -1, we're going to go down 1. All right. Now let's find our key points. All right, always start at 0. After 0 are our quarterly intervals, so pi times a quarter, pi times a half, and pi times 3/4, and then the period. All right, so then we're going to get pi over 4, pi over 2, and 3 pi over 4. All right, so I'm going to use these points to label the axes. So we're going to have a 0, pi over 4, pi over 2, 3 pi over 4, and a 2 pi. All right, our amplitude was 4, so I'm going to label that on our graph. We're going to go up 4 units, down 4 units. All right, remember sine always starts at 0. And then the next quarterly mark is going to be at the highest point. The halfway mark, we're going to go back down to 0. 3/4 of the way, we're going to go down to the lowest point, -4, sorry. And then at 2 pi, the full period, we're going to go back to 0. Always end where you start. All right, so this is one cycle, right? I'm drawing a little dotted line because this isn't the final answer, right? Remember that we need to shift it down. Right, so we're going to shift everything, all these points down 1 unit. So down 1, down 1, down 1, down 1, and down 1. Right, and then we don't have any reflection, so this is our final graph. All right, so it's going to look something like that. All right, and then just continue it in both directions. All right, so try not to be messy. All right, so that you can clearly make sure that it looks like a clear pattern, all right, as your final answer. All right, so it should look something like that. All right, and those are your examples on graphing sine functions. All right, this next page we're going to do cosine functions. All right, now the graphs for cosine, finding the information is going to be exactly the same as sine, right? So I'm going to start there, and then once it gets different is when I'll start showing you guys exactly what we're going to do. All right, our amplitude, always check the number out front. We don't see anything, we assume it's a 1. Our amplitude is 1 here. Our period, it's going to be 2 pi over whatever's inside of our sine or cosine function. In this case, it's a 2x, right? So it's going to be divided by 2, and then we end up with pi as our period, simplified. Right, these cancel out. Reflection, I have none. I don't see a negative. Vertical shift, I don't have any plus or minus, right? So none. All right. Once again, exact same steps as sine. So I'm going to find my key points. We actually have the exact same period as we did in the previous problem. So I'm just going to reuse those points, right? 0, it was pi over 4, pi over 2, 3 pi over 4, and pi. Right? If you're not comfortable with how I got that, go to question number 4. I get these exact same key points because we have the same period. All right. So now I'm going to label these on the graph. 0, pi over 4, pi over 2, 3 pi over 4, and pi. All right. Our amplitude is 1. So the highest it's going to go is 1. The lowest it's going to go is -1. All right, so this is where it gets a little bit different. Keep in mind the graph for cosine is going to start not at 0 like sine. So remember, sine of 0, we said that that's 0. Cosine of 0, right, this is something that you guys have to commit to memory. Cosine of 0 is going to be 1. If you don't remember that, do it enough times so that you do remember it. Cosine of 0 is going to get you 1. Or if you absolutely need to, draw a point on the x-axis, label 0 degrees, and get a point 1 comma 0 and do your x over r, right? Remember, cosine is x over r. In this case, r would be 1. You get 1 over 1, which would be 1, right? And that's something that we did a little bit ago, right? If that's confusing, just memorize this part. Cosine of 0 is 1, right? That's your highest point. So we're immediately going to start by plotting a point at 1. All right. And then the pattern's going to be exactly the same. If we're starting at our highest point, our next point, we can only go down, right? So we're going to go to 0. At pi over 2, it's going to be at its lowest. At 3 pi over 4, it's going to go back to 0. And at pi, it's going to finish at 1, right? So again, just like with sine, always finish where you started. And then you get points that, if you connect it, kind of look like a V, right? But again, you want to make sure that you have that curve shape to it. So that's one cycle. So you can see that this clearly looks different from one sine cycle, right? A cosine cycle looks different, but if you keep going, right, now this is important. If you keep going, notice that it looks very similar to our sine function, right? They look almost identical, just starting at different spots. All right, so it's still going to have that same wave shape, right? Your 5 points are just going to be different, right? Only difference with cosine, right? Everything else is exactly the same. All right, so let's try the same thing with number 6. Our amplitude here, I see a 2 in front, so that's going to be our amplitude. Our period, it's going to be cosine of 1x, so it's going to be 2 pi over 1, which is just 2 pi. Reflection, I don't see a negative out front. We're not going to have anything. Vertical shift is also going to be none, right? I don't see anything added or subtracted. All right, let's find our key points. Zero is always going to be one of them. The others, you're going to take your period and multiply it by a quarter, a half, and 3/4. And then the period itself is going to be your next key point. All right, we've done these before, so I'm going to go ahead and simplify it. If you're not comfortable with that, go to questions 1 and 3. We do the same exact period in those problems. All right, so we get pi over 2, pi, 3 pi over 2, and then 2 pi is the last one. All right, so I'm going to use those points to label our axes. 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, our amplitude here was 2, so the highest it's going to go is 2. The lowest it's going to go is -2. All right, and now with cosine, we had said that it doesn't start at 0, it starts at 1. Keep in mind, if I have a 2 in front of it, that's the same as saying 2 times cosine of 0. And if cosine of 0 is 1, this is 2 times 1, which is just 2. All right, so we're going to start at our highest point. So that's another way to think of it. You're always going to start at the highest point, no matter what number's in front of it, right? Whatever number that you see in front of here is where you're going to start. All right, your next quarter interval, you're going to go down. At the pi mark, the halfway mark, it's going to go to the lowest. All right, the next quarter interval, you're going to go back up to 0, and at the period itself, you're going to end where you started. All right, there's no shifting or reflection, so I can just complete the graph like this. All right, so that is one cycle. Now all you have to do is complete it in both directions. So it's going to look something like that. All right, we get that same wave that we've been getting before. All right. Let's try the same thing with the next one. All right, let's find our information. Our amplitude is whatever's in front. I see a -3, but we only need the absolute value of it, so I'm just going to do 3. Our period, this is cosine of 1x. Once again, it's just 2 pi. All right, completely unchanged. Our reflection, we do have a negative, so we are going to reflect here. And we also have a vertical shift. There's a +1, so we're going to go up 1. And for our key points, exact same as the previous problem. So they're going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, so I'm going to go ahead and label the axes 0, pi over 2, pi, 3 pi over 2, and 2 pi. My amplitude was 3, so the highest I'm going to go is 3, the lowest is -3. Now once again, cosine always starts at the highest point, so I'm going to draw a point at 3, and then same exact pattern as before. Right, you get this little shape right here. Right, I'm drawing it dotted this time because this isn't going to be our final graph. We do have a reflection and we do have a shift. All right, so I'm going to reflect it. Reflect all of these points over the x-axis. We started at 3, so we're going to start at -3 now. 0 reflected is itself. At -3, we're going to reflect it to a +3. Once again, 0 is reflected is just 0. And then at 3, it's going to become a -3. All right, so that's one cycle that's reflected. And then our shifting, we're going to go up 1. All right, so I would take all the points that we just drew in blue, move everything up 1 unit. Up 1, up 1. Right, all of these points in blue, shift them up 1 unit. Right, and that accounts for all of our transformations. So I'm going to go ahead and connect these points now. All right, so it's going to look something like that. And then just complete it in both directions. All right. All right, let's finish with this one. Amplitude, whatever's in front of our function, it's going to be a 3. Period, it's going to be 2 pi divided by whatever's inside with the x. So 2 pi over 3. Reflection, there's no negative out front, so I'm going to write none. And a vertical shift, we're going to go up 2. All right, let's find our key points, same as before. It's going to be 0. The next few are going to be at the quarterly interval, so 2 pi over 3 times a quarter, times a half, and times 3/4. And the last one's just going to be the period. All right, so 2 pi times a quarter, 2 pi over 3 times a quarter is going to get you 2 pi over 12, which is pi over 6. All right, now 2 pi over 3 times a half is going to get you 2 pi over 6, which is 1 pi over 3. All right, always simplify these. Now 2 pi over 3 times 3/4 is going to get you 6 pi over 12, which is going to get you pi over 2. And then we have the period itself. All right, so we're going to use these to label the axis. It's going to be at 0, pi over 6, pi over 3, pi over 2, and then 2 pi over 3. All right, our amplitude is 3, so the highest point that we're going to go is 3, the lowest is at -3, and then I would plot some points, right? Remember, cosine is always going to start at the highest, and then at the quarterly intervals, we're going to go down and then back up. All right, so it's going to look something like that. All right, keep in mind, we do want to go up from this point 2 units. All right, so move everything up 2 units, everything up. All right, and then we get a graph that looks something like that. We don't have a reflection, so we can make a solid line here. And then from here, all you want to do is just continue it in both directions. Okay, so it's going to look something like that. Again, as long as I see the 5 key points, that's all that really matters. If you continue it in both directions and it's not 100% accurate, fine. As long as I see the 5 key points and that you make an effort to have the consistent pattern. All right, so that covers all 8 of these problems. This is excellent review for your quiz. This makes up a majority of what you're going to see.